So in this problem, we need to find the electric potential at the center of this configuration right here. So this is the diagram from problem 2.15, so we've solved this before. So we're going to take that result and then we're going to find the potential at the very center of this configuration. So for starters, I'm going to assume that you've already solved problem 2.15. So this is the answer of problem 2.15. You're told to find the electric field. So using this and then using this formula right here, we can actually find the potential at the center of the configuration. So let's start from here. So the potential at the center, which is at the point 0, according to the formula, is starting from infinity going all the way to 0. Times of the electric field dot dl. And we'll have to break this up into different cases. So from infinity to b, we're going to have to consider this electric field. So that is k over epsilon b minus a r squared dr. And then moving on from b to a, we're going to have to follow this electric field. So from b to a, it's going to be k over epsilon r minus a divided by r squared dr. And then from a to 0, because the electric field within that area is going to be equal to 0, we essentially don't have a third term here. So all we have to do is just to solve this integral. So that is easily done. So I'll just pull out the constant. So for this part, for the 1 over r squared, integrating that, we'll get negative 1 over r, and that goes from infinity to b. And then pulling the constant out, so c here we have 1 over r minus a over r squared. So integrating that, we'll get natural log r plus a over r. And that goes from b to a. So let's substitute the numbers in. So b minus a. So let's substitute b and we get negative 1 over b, and then the 1 over infinity is equal to 0, so we don't have to write that. So for the natural log, we'll have natural log a minus natural log b, so that gives us natural log a over b. Plus, while substituting a, we get a 1, then minus a over b. So let's rearrange this result for a bit. So let's pull out the constants first. So we see we have a b minus a, so this is multiplied with a negative 1 over b, so you can see that we can obtain a negative 1 plus a over b. So let's just do that, negative 1 plus a over b. And for the right hand side, you see we have a plus 1 minus a over b. So the plus 1 minus a over b. And then we also have the natural log, plus natural log of a over b. We'll see that these terms cancel each other out perfectly. So that have negative k over epsilon, negative natural log a over b. And we can get rid of the negative sign by switching the order of the fraction. So there we have it. This is the potential at the very center of the configuration. So this is the answer.